fission even means splitting. So let's look at the definition. Let's put it down. Nuclear fission. So let's look up. So we can see here, nuclear fission is the splitting. That's what fission actually means. Splitting. Now, nuclear fission is the splitting of a heavy atomic nucleus. Now, what will bring out the splitting of the heavy atomic nucleus is when such a heavy atomic nucleus is bombarded with a fast-moving neutron. When a heavy atomic nucleus is bombarded with a fast-moving neutron, that particular atomic nucleus, singular, can split into two nuclei. You can see two nuclei, that's plural, of relatively equal masses or sizes, follow with the release of large amount of heat and also more neutrons. As a matter of fact, only one neutron is needed to bring about fission, but more than one neutrons will be produced after that particular fission. Let's see what happens if uranium-235 with atomic number 92 undergoes fission when bombarded with a neutron. It will split into two nuclei. Let's look at the two nuclei. 141, 56 barium plus 92, 36 krypton plus 3 neutrons. Now, let's look up. Please pay very good attention here. Now, this is the uranium that undergoes. This is a heavy atomic nucleus. And when it was bombarded with a neutron, what happens to it? It splits into how many nuclei now? Barium nuclei, barium nucleus, and krypton nucleus. And what is produced also? Exactly. So you can see how many neutrons was actually used at the beginning. 1. But in the process, 3 neutrons. So that's the meaning of more neutrons. And also, you also see that energy in form of heat will also be produced here. And like I've told you before, you have to ensure that your equation is balanced. On the left-hand side here, the mass number on the left-hand side must be equal to the mass number on the right-hand side. The atomic number on the left-hand side must be equal to sum of the atomic number on the right-hand side. Let's look at this one. 231 plus 1 gives us what? That's 2. That's for mass number, mass number. So on the left-hand side now, on the left-hand side, that's 236. Now, let's find out on the right-hand side. This 141 plus 92. What does that give us? 233. Now, remember, these 3 affect everything in this bracket. That's 3 times 1. That's 3. If you add 3 to it, what does it give you? So you can see it balances. Now, if you come to the atomic number, this 92. 92 plus 0 gives us C92. Now, let's look at 56 plus 56. Now, this one is 3 times 0. So it's 0. 0 plus 96 still gives us that. So we have to ensure when we are writing this that everything is balanced. Because even at times, you can actually be given an equation like this, but instead of this to be written like this, you can have something like this. You can have this uranium-235 92 plus 1 0. As a matter of fact, instead of this, you can have here, they will simply write neutron, then 14156 barium, then plus X, Y, krypton, then plus 3 neutrons. And then the question will be, in the equation above, the respective values of X and Y are, so they expect you to use this equation to find out what will be the mass number, which is X of krypton, what will be the atomic number, which is Y of krypton. And they just use a simple mathematics because we know that neutron, you have to know that your neutron, I've given you the table before. What do we use to represent neutron? 1, 0, n. So you just replace this 1 with 1, 0, n. So that we just carry out a simple mathematics here. 235 plus 1, that's 236, which is equal to, here we now have 141 plus here, that's X, plus 3 times 1, that's 3. So that's going to be 236 is equal to 141 plus 3. That's 144 plus X. And then if we bring this one here, we have 236 minus 144 is equal to X. What did this one give us? 90. Because some people are saying 91 now. So 92, that's that. So you can see that's how this one came about. And if you want to find for Y here, we just do the same thing with this one. That's 92 plus 0. That's going to be 92 is equal to 56 plus Y plus 3 times 0. That's 0. So which means that 92 now is equal to 56 plus 0 is 56. That's plus Y. And if you bring 56 here, it becomes negative. 92 minus 56 is equal to Y. And what did I give us? So which means Y is equal to 36. So that is some of the questions you can actually come across. You should know how to balance your nuclear equations like this. So let's put this down. So let's look up. So you can see the reaction started with one neutron. One neutron is used to bombard uranium-235. And the uranium-235 splits to produce two nuclei of relatively equal sizes, barium nucleus and krypton nucleus. And it didn't stop there. There is production of how many more neutrons? 3. Now, these 3 neutrons can also go ahead to bombard the uranium nucleus again to bring about more fission and production of more neutrons, and the more neutron produced can also bombard with another uranium nucleus, and it just goes on and on and on like that. A sustaining reaction. We refer to it as a chain reaction. As a matter of fact, if you say a chain of events, let's say something chain reaction. So let's say something happens. Now, if somebody slaps you, and in anger, you slap him back, and because of that, now your parents who witnessed it were like, "Why are you slapping my son?" And then the two parents now got involved in a fight. Now you're now having a sequence, a chain of events that is caused by the slapping of one person by the other. We are talking about chain reaction. We are talking about a reaction that is sustaining. One reaction leads to another one, that another reaction leads to another one. This neutron leads to the production of more neutrons. This particular fission leads to the production of 3 neutrons. The neutrons that are produced can also bring about fission of more uranium, and more neutrons will be produced, and those neutrons will keep on causing more and more fission, and it is self-sustaining. It can go on and on and on and on like that. That is what I meant here. The 3 neutrons that are referring to these 3 neutrons can go on to initiate further fission of the uranium, thus leading to a chain reaction. So please, let's take note of this. So this is basically what nuclear fission is about. When a heavy atomic nucleus, like a uranium atom, is bombarded with a neutron, and that brings about the splitting of that heavy nucleus into two nuclei of relatively equal masses with the emission of more neutrons and energy. So that's for this. And don't forget, you also have to note that nuclear fission, please put it down. Nuclear fission is the basis for atomic bomb. Atomic bomb. We all know what atomic bomb is. So atomic bomb is based on nuclear fission. So let's take note of this. After this, we'll be looking at nuclear fusion now. So let's put the definition down, then I will explain afterwards. Nuclear fusion. And radiation. So let's take up. So nuclear fusion. Now we are talking about fusion, F-U-S-I-O-N. Even the word fusion comes from the verb fuse, F-U-S-E. When you are fusing two things, you are joining them together. In fusion, one heavy nucleus is split into two nuclei of relatively equal sizes, but the exact opposite happens here. In fusion, two light nuclei are combined, are fused together to form a heavier atomic nucleus with the release of huge amount of heat and radiation. As a matter of fact, as I'm going to see, when we are finding out the difference between them, the amount of heat produced during nuclear fusion is higher than the amount of heat produced during nuclear fission. Not only that, take note that energy from the sun, energy of the sun is believed to come from nuclear fission. Nuclear fusion, rather. So you can see the sun is the ultimate source of energy in the universe. So that particular energy that we get from the sun is actually derived from nuclear fusion. And not only that, nuclear fusion is the basis for hydrogen bomb. Now, know the difference between them. Hydrogen bomb is one of the most deadliest, if not the most deadly bomb that ever existed. Hydrogen bomb is actually more dangerous and is far more destructive than atomic bomb. So, what is the basis for atomic bomb? Nuclear fission. But the basis for hydrogen bomb is nuclear fusion. Now, let's look at how nuclear fusion happens. Imagine that if you have two atoms, if you have two light atoms of, let's look up, this 21H plus 21H. What's 21H? That's deuterium or heavy water. When they combine together, what do we get? 4,2He plus it. Now, this is what we refer to as nuclear fusion. You can see two light nuclei combine together to form a heavier nucleus because the atom of helium is heavier than atom of the deuterium or heavy water air. Not only that, what if you have something like 31H, that's tritium, plus say something like 21H. Now this one can give us 42He plus, what do you think we're going to have here? Plus what? Plus 10 neutron, then plus heat. So this is another example of a nuclear fusion. Is that understood? So that's what happens. During nuclear fusion, two light nuclei will combine together to form a heavier nucleus, singular. So these two combine together to form an atom of helium. These two combine together, this tritium, this deuterium, to form an atom of helium, and it emits one neutron and also huge amount of heat. So let's bring it to a close by finding out what are the differences between the two of them. What is the difference between nuclear fission on one hand and nuclear fusion on the other hand? So, like I've said, even from their definition, for nuclear fission, it involves splitting of a heavier nucleus into two nuclei. Whereas nuclear fusion involves fusion of two light nuclei to form a heavier nucleus. Not only that, okay, so now these are just four out of the various differences between a nuclear fission and a nuclear fusion. Let's look at them one after the other. Even from the definition, nuclear fission involves the splitting of a heavier atomic nucleus into how many nuclei? Into two nuclei of relatively equal sizes. Whereas, on the other hand, nuclear fusion involves the fusion or the joining or the combination of two light nuclei to produce a heavier atomic nucleus. That's one of the differences. Number two, nuclear fission can take place at ordinary temperature. However, nuclear fusion, on the other hand, takes place at extremely high temperature. It requires high amount of temperature. And you might want to ask, why does it need high amount of temperature? Don't forget, imagine, let's look at this. Because I told you that this equation here represents a nuclear fusion. When two deuterium atoms are brought together, fused together to produce a helium atom. Don't forget, the nucleus of this particular deuterium is positively charged, isn't it? And the nucleus of the deuterium is also positively charged. When you bring two positively charged nuclei close to each other, what do you think will happen? There's going to be a force of repulsion. So you require a high amount of energy in form of heat to overcome that repulsive forces. Even that is why you call, most of the time, they refer to nuclear fusion reaction as thermonuclear reaction. What does the word thermo there symbolizes? Temperature exactly, or heat. So nuclear fusion requires high amount of heat for it to take place, whereas nuclear fission can take place at ordinary temperature. Number three, nuclear fission, even though both of them produces heat energy, but nuclear fission produces lesser energy in comparison to the amount of energy produced during nuclear fusion. And finally, from what I've explained to you earlier, nuclear fission is the basis for an atomic bomb, whereas nuclear fusion is the basis for what kind of bomb? For hydrogen bomb. So these four summarizes the differences between nuclear fission and nuclear fusion. So we just put a stop to it here. So take care, guys. Yeah, yeah, yeah.